Welcome everyone. In this session, we will walk through the basics of R programming. I will show you how to set up your workspace and handle few simple tasks that help keep your work clean and organized. We will start from creating a working directory, setting up a project and writing code to manage file and save output. Let's start with working directory. What is working directory? Working directory is a main folder where R looks for files and save your output. To check what is your current working directory, we have a command that is getwd. To run this line of command, use this run button, or use a keyboard shortcut. Here you can see the output in the console. At this moment, a document folder is my current working directory. If I want to change this working directory, we have a command setwd, where within these parentheses you have to mention your path to that folder, or you can select manually. Go to the session option, set working directory, choose this option, then choose directory. So a window will pop up. From this window, you can select any folder. Like at this time, I am selecting this document folder, main document folder. Within that, I have a data analysis folder. So I select that. Now, my current working directory is set to be data analysis. To check if it's set correctly or not, run this command again. Now, from documents folder to my current working directory is data analysis folder. Remember that if you copy a path from Windows, it will have backslashes like that. Let me show you. Like if I want to make this microarray analysis folder as my working directory, so I have to copy this path. And if I paste here in the command setwd quotation marks then path, R throws an error. But if I replace backslash with forward using same command setwd, now replace all the slashes. Now run this line of command. So at this time, the command runs successfully. To check if it's set successfully or not, now from data analysis folder to microarray data analysis has set to be current working directory. Or you can do one more thing. You can add double backslashes to make this code work. So these two codes work, but this code throws an error. To work in a more organized way, we create projects that help us to stay organized. To do so, go to this file menu, select new project. Then here you have different options. You can create new directory, new folder to make a project, or you can convert your existing directory into a project. Let's select this new directory option, then new project. Name your project. Let's say data analysis. Select the subdirectory where you want to save this folder or a project, like I want to save this on my desktop. Then open it and create project. A new window will start, and if you look at here at the top right corner, a folder, a project named with data analysis has been created. If you scroll down, you can switch between your project. Now project folder has been created, but to organize this project folder, your project folder should have some subfolders, like one subfolder for a data, then second for scripts where you can save your R scripts, and third for results. So to create subfolders within your main project, we have a command directory.create. Here you just have to mention your folder name, let's say data. Now create next folder with same code, at this time script. Then the third folder for results. If you check here, all three folder has been created within this data analysis main folder. So in this way, you can create folder in R. You can create locally as well. Let's talk about how our codes work. Basically, R understand commands that follow a certain structure, and most of the time, this structure is looks like function that followed by the argument. But that means like we have a function print. Within this print function, if I mention anything, biotechnology, this is my argument or input. If I run this line of a command, it shows the output in the console. So in R, every function is followed by these parentheses, and you have to write everything within that parenthesis. If you write outside the parenthesis, R will not work, or it will not consider it as a command. Now let's create another variable and take a look how it actually works. Now create a simple variable with name gene expression and insert some random numbers 2.3, 3.8, 3.9, 5.6 and 9.4. Run this line of code. Here at this time, you can see the difference. Now R shows just the as it is same command, same code, but no output after this line. But if you look at here in the environment section, you have a variable name gene expression with the values. So when we create variable, this is what we are creating a variable. This gene expression is variable name, and this less than and dash sign is called as an assignment operator, which is used to store this value within gene expression variable. So if you want to store any object in your current session, you can use this. You can create variable and save it to your environment. If you don't want to save it, you can directly run command without this variable creation. Like if I want to calculate the mean of this gene expression value, I will use this mean function. Then within this, I will mention the gene expression variable name and will run this line of command. Make sure when you run R command, insert your cursor anywhere in between the line. Don't select any section of your code. If you highlight only part of a line, R might throw an error or not run it properly. So I run this line of command, and in console I have a output with mean value of 5. But in this time, I don't have anything in environment section. But if I assign a variable mean result by using this assignment operator, and again if I run this line of code, so at this time I don't have any output in the console but output in the environment section. So what is the difference? The difference is only one thing. When you create a variable, you can save this output for a later use in your local system, but the results in the console, you cannot save the results from the console. Let's plot some simple plots. Insert the variable name gene expression. Here you can see in the plot tab. Similarly, we can plot a simple histogram using hist function, gene expression. Now histogram has been created. One more plot, that is bar plot. Let's create with the same. So bar plot also created. To save this, use export function. You can save as image or you can save as PDF. PDF is more recommended for high resolution. To check the basic statistics of your data, we have a function that is summary. Here insert gene expression name. Now you can see the output in the console. Works with different type of data. So common types are numeric, either positive or a negative. Like if I create a variable x with value 24, and you can see the output, the variable x is the numeric data type. Similarly, create another variable with a negative value y. Check the class of this y variable. It is also a numeric. Next data type is integer, that are whole number, but by default are classify both whole numbers and the decimal numbers as a numeric class. In the above case, I create two variables without decimal points and R classify them as a numeric. But the difference is that R identified numeric, R can distinguish between numeric and the integer number by using a sign, by using a letter L that defines as an integer number. Let's check the same example. Create a value z with same this 24, number 24. So at this time I add this L up alphabet here and run this line of command. Again check this, check the class of z variable. So now I'll classify this 24 that is followed by L as integer. So why we use integer? Because integer data consume less memory, so it is useful for the large data set or machine learning pipelines. But you have to be careful when you want to convert your data into your data from a numeric to an integer, because R reduce the decimal point to convert the numeric data into. Let's create a variable 1 with numeric data with decimal point. Let's convert this class variable 1. This is a numeric class. Convert this numeric class to a integer. Convert numeric data into integer. We have a command as dot integer, then the followed by variable number. So you can see the output. Previously it was 28.4, now it's 28. Then 23.7 replaced with 23 and 2.9 with 2. So in this way you can convert your numeric data to integer, or if you want to convert integer to numeric, we have a command as dot numeric. Let assign a variable name, variable 2. Now convert this variable 2 into a numeric and check the class of assign a name of variable as variable 3 and run again this command. Now check the class of variable 3 into numeric. So if you see here, we have created a variable 1 with decimal points. So in the next step, we convert this variable 1 into a integer by replacing and store the value into variable 2. So variable 2 with integer class has been created, but at this time decimal points are removed. So when we convert this integer to again numeric, the decimal point is still not there, but the class of the data type is converted into a numeric. So in this way we can convert numeric data to integer. Next we have a character data, which we called a, for string data we use quotation mark, either double or a single, to define them. Like we have to mention like this: gene 1, gene 2 and gene 3. Let's check the class of this variable character. If we don't add the quotation marks, or consider them as a variable name. Let me create this and run this line of a code to show you output. So here R throws an error, but the error is object gene 1 is not found. So what happened when I run this line of a command, R without quotation mark, R consider this gene 1 as a variable name. So when we execute this line of a command, R search all the variable name here in the environment section, and it didn't find any variable name with gene 1 name. So that's why it throws an error, gene 1 not found. Similarly, if you add quotation, take numbers like quotation which followed by, if I write the numbers like this and execute this line of code, so let's check the class. If you check the class here, it's mentioned the character. Even it's not a character variable. So it will consider a mistake when we analyze our data, because you cannot apply any statistical or machine learning function on the character data. Let's say if I want to calculate the mean of this variable 6, output is NA, and what is warning message that says argument is not numeric or logical, so returning NA. So argument should be a numeric. If I correct this variable, if I remove this quotation mark or create a new variable with the same values, 4.6, and run this line of a command. Let's calculate the mean of this variable 7. So at this time, it calculates the mean of this variable 7, but variable 6 mean is not calculated because it's a character variable. Next, we have a factor data type. Factors are basically used to represent categorical data such as group, disease status, gender. So it can be written as a character or a numeric type. Disease status of 5 patient, cancer, normal, cancer, normal, then let's say cancer again and normal, again cancer. So this is the disease status of 5 patient. Let's say check the class of this variable, that is character. Now convert the class into factor type. To do so, into a factor, we have a command as dot factor. Here mention the disease status column and run this line of command. Now check the class of this disease status underscore factor. Now it's converted into a factor. Check it how it looks like. Disease status factor. So it's classified as a cancer and a normal category. If you want to assign a levels to these categories, we can do. Okay, I'll assign the categories in alphabetical order. So cancer is the first class and the normal is the second. So in gene expression analysis or machine learning pipelines, we have to consider this example. Either we want to compare cancer versus normal or a normal versus cancer. For that, we have to re-level our factor classes by using a command factor. At this time, we use just a factor, not this s dot factor. Here, we'll mention the same disease status factor. We will use levels. See, we want normal first, then next level is cancer. Run this line of command, and so now levels has been changed from cancer and normal to normal versus cancer. So in this way, we can convert factors and re-level our factor order. Last is the logical data type. That is not actually the class of a data, but it depends on the all these other 4 data types. Let's say create a one variable with the name of age. This is the variable age. Now to specify the logical condition, we specify age. Here we specify this variable that we want to create a logical condition based on this variable age. Then we define less than 25 and run this line of a command. Check the output. It provides the logic that first number is 23, that is less than 25. So logical condition is true. Second is 24, that is equals to 25. That's why 25 that is equals to 25. So condition is false here, and 28 is also greater than 25. So only first condition is true, and rest are the false. So in this way, we can create the data types, or we can work with different data types. Let's see with the example of a real data. So to import CSV data, we have a command read.csv. Let's say data read.csv. Then file.choose. Run this line of command. It will pop up a window. Select the data. I will select this metadata. Open it. View this data in our source editor panel. So this is our data that contain few columns. First is name column, then height, gender, age, and weight. So first, check the structure of the data by using the structure function. Variable name, that is data. So here, this is the data.frame structure with 10 rows and 5 columns. Against the name of each column, data type has been mentioned. Data type is mentioned. First column is a name, that is a character vector. It's right. Second is height, that is tall, short, and medium. So we know this is not a character vector. Vector data type. It's a vector. So we will convert this height column into a vector. Next, we have a gender column. That is also a character data type. We will convert this as well. Age column is in right format, integer that are whole numbers. Weight in numeric format because these are decimal points. So to convert height and gender column into a vector, we will use data by using selector column and height vector. We will create a new column with the name of height vector. Then we want to convert this. First, we need to convert this character vector into a vector by using function factor. Next, we will relevel these. Then we will relevel it. S dot factor, data with column height. We want to convert this data column into a height. Let's check our data column data. So a new column has been created with the same data, but if we check the class at this time, sorry, structure of the data. So height factor column is converted into a factor with 3 levels. Check the levels of this column: medium, short, and tall. So it relevel according to alphabetical order. Now relevel height factor column into tall, medium, and short. At this time, we will not create a new column, but we will relevel this same column with the function factor data with factor levels equals to, we want tall first, then we want medium, and then short. Run this line of command, and now check the levels again of this column. Now column has been changed from tall, medium to short. So in this way, we can convert and relevel our character data into a factor. Similarly, convert the age column into a factor by using age factor column first factor, then data. We want to convert age column into a factor. Run this line of command. A new column has been added. Levels of data with age factor. Sorry, not age column, but a gender column. We don't need to convert age column. We will convert gender column. If I check it, so gender column is created with the same data, but let's check the type. So now convert this male and female into a 0 and 1. Convert character factor into a numeric factor. To do so, data into a gender, let's say numeric, but it's a numeric factor, not a numeric number. Here we use if else statement, if else data with column gender factor, if equals to what, female. Make sure you type the same alphabet or to avoid any typo, then assign a number of 1, otherwise 0. What this line of code will do, it will find the female data points from this column gender factor, and as if gender is female, then it will assign the number 1. If it's not true, then it will assign the number 0 for a male. So now run this kind of a command and check. So in this new column, for a male, 0 has been added, and for female, 1. So in this way, we can convert character data into a numeric, but at this time, this is in a numeric data type. We have to convert it into a factor. To do so, we will use again the same factor function, same column. We don't need to change the column name at this time. Just simply we'll use s dot factor, again data, same column name which we want to convert into a factor, and run this line of command. Now check the class again with data into a numeric. So now at this time it's in a factor. So in this way you can convert the one data type to another. Now after working in R, if you want to save your script, so to save your R script, go to this file menu, select save as, name your file, save this in a script folder, name it like R course, and save it. Within this script folder, if you check it with .r extension, R script file has been saved. Script has saved. So R script will save with .r extension. If you want to open this R script, use a keyboard shortcut, that is Control plus Enter. Oh, sorry, Control plus O, or go to this file menu or open file. You can open it. Next, if you want to save any file in CSV format, we have a command write.csv. Let's say I will save this disease status file Then I have to specify the variable name, that is the file of that file of the data. Then file equals to, here I have to mention the file name. Another important thing, we have create a folder. So to save the in the result folder, so to save it in a result folder, first mention the name of folder, that is results, then slash, and now the file name. You can say patient data and add the extension, that is the .csv. Run this line of command, check the results folder. So in result folder, we have a file with patient data. If you don't mention this extension, this path, it will directly save in this data analysis folder. And if you don't mention the extension, it will not save properly. So to save in a proper folder and in a proper format, you have to add these both things. Similarly, if you want to save this entire space, workspace, so like that way, if your work is not completed yet, you want to continue it, you want to use any data type or any object from this workspace, you want to save it. So to save workspace, we have different options. First, so to save all the objects, you can use the command save.image, and here you can also mention the path. Here you can create a one more folder for workspace, but at this time I don't have any folder specified for workspace, so I will directly save in data analysis folder. Just at this time I will add file name, that will be R data. R and G is capital. So let's save it. So you can see here full workspace R data is saved in main for data analysis folder. If you want to save any one object or one or two objects, so we have a, that is just save. Here you can mention the folder here you can mention the object you want to save, like I want to save gene expression, then disease status variable, and saved here in the data analysis folder. To load workspace in R again, we have a function that we call. Now here mention the name of the workspace you want to import here. Let me clear this first. Now I want to import this one first to check if it saved two objects or not. Now you can see here disease status and gene expression data is only visible. Similarly, if I clear this and again I will load this full workspace and run this line of command, so you can see the entire workspace now has been available to work with. So in this way you can continue your work in R. So that's all about this session. In the next session